Okay, so for the 2016 exam for the calculator portion of the multiple choice, okay, we're looking at this number 76, and it says a music group expects to sell new compact discs, CDs, okay, at a rate, who uses CDs anymore, right? Okay, at a rate R of t is equal to 20,000 e to the negative 0.12 t CDs per week. Okay, so this is a rate, right? So that means this is a derivative, okay, where t denotes the number of weeks since the CD was first released to the nearest thousand. How many CDs are expected to be sold during the first 12 weeks after the release? Okay, so we want to know the accumulation of all the CDs that are sold. Well, that would be an integral, right? Because if we integrate a rate, we're going to get back with the number of CDs. Okay, so we're going to integrate from 0 to 12 of this R of t function, right? R of t and then dt. So this is the R of t is CDs per week. So CDs over weeks, and dt is weeks. So when you multiply those, you're going to get number of CDs, okay? And we want to the nearest thousand, okay? All right, so we need to put this in our calculator, and we're going to get an approximation. So I'm going to go in my calculator and do that, okay? So what I want to do is I want to integrate. So I'm going to go alpha window and then number 4 function integrate, right? And we want to go from 0 to 12. And you could put R of t into the y1 and just use y1 here if you want to. We're only using this for one problem, so I would just type it in right now. So 20 and 1,000. Okay, just make sure we typed in 20,000, and we did. Okay, and then e to the negative 0.12 t. Okay, I made a mistake earlier with AB, and I'm going to tell you it was a mistake that just I didn't check my work. Okay, I typed it in wrong. Okay, and I got it wrong. I knew how to do the problem, but I got it wrong. Okay, so just check to make sure you're typing it in right. So this was e to the negative 0.12. I probably shouldn't be talking and trying to type at the same time either, huh? Okay, so dx. Okay, so that's 20,000 e to the negative 0.12 t, or x in this case, and we press enter. Okay, so to the nearest thousand, right, this would be 127,000, okay, to the nearest thousand, okay, because this would be hundreds, and then right here's the thousands place, right, and this is a 1, so it's just 127,000. Okay, back to my, so for this integral, from the calculator, we got 127,000. Okay, and so that the correct answer is D. Okay, all right, so let's go on to 77. Okay, so 77, they're giving you a function that's continuous on the closed interval, so there's no breaks, right? And so with f of 1 equal to 10 and f of 3 equal to 18, which of the following statements must be true? Okay, does f of 2, which is between 1 and 3, does it have to be between 10 and 18? And no, it doesn't. You could have a maximum that's bigger than 18, or you could have a minimum that's lower than 10, right, in between. You don't know what's happening in between. These are just endpoints of this interval 1 to 3, okay? So you really don't know what's happening in between. So it can't be A. And we just kind of have to go through these, okay? F is increasing on the interval 1 to 3. Well, it kind of looks like it, right, because the left endpoint is lower than the right endpoint. But again, you don't know what's happening in between 1 and 3. They don't tell you that, right? They don't tell you that the derivative is always positive. They would have to tell you that to say this, okay, to say f is increasing. So we don't know. It could be going up. We could have a maximum in between here, and then it would be increasing and decreasing, okay? So f of x equals 17 has at least one solution on the interval. So that means the function has to take on the value of 17 for one number between 1 and 3. That's true, okay? That's the intermediate value theorem, right? So we have 10 and 18. We have to hit every intermediate value in between, and where that's happening is for an x value between 1 and 3. So we have to hit every value between 10 and 18, and 17 is between 10 and 18. So this is testing you on the intermediate value theorem, okay? All right, so the correct answer is C, but I want to go through, okay, D, okay? So f prime of x is equal to 8, okay? So that's kind of like the mean value theorem, right? But that would only be true if the average rate of change between 1 and 3, okay, was 8, and that's not the case, okay? Because 18 minus 10 is 8, so this would be 8 over 3 minus 1, which is 2. So this is 8 over 2. This would be f prime of 4. So if this had f prime of 4, you'd have to pick this one too, okay? All right? Okay, so it's not this one because it says it's 8. It would have to be 4. okay? And then the integral from 1 to 3 f of x dx is greater than 20. There's no way to know, okay? Because you don't know, again, you don't know what's happening in between. You could have more of the function below the x-axis than you do above the x-axis, and then, you know, if that happens, then this integral would have come out to be negative, okay? All right, so that's number 77. Let's go on to 78. This would be a great question on this year's exam, I think, okay? Because it's not like a textbook problem, okay? You have to use graphs, and and they're testing you on the product rule too, right? Okay, so h of x is defined as f of x times g of x. So you first have to find h prime of x. I would do that first, okay? So h prime of x is f prime of x times g of x plus f of x times g prime of x. And so we need to find h prime of 2. And we're given the graph of f, and we're given the graph of g, okay? So h prime of 2 is equal to f prime of 2. That would be the slope of the function f at 2. And then g of 2 plus f of 2, and then g prime of 2. So this would be the graph, this would be the slope of the graph at g at x equals 2, okay? So then f prime of 2, so we look right here. Okay, so right here is 2. What's the slope right here? Right, what's the slope? Okay, so it's nice because this is going by ones, right? So it's going to go up 2 and right 1. So the slope is, this slope right here on either side is 2, right? So this would be 2 times g of 2. And if you look g of 2, that's just the value of the function at 2. So that would be 5. So this would be 2 times 5. And then plus f of 2. F of 2 is 4. That's just the function value at 2. And then now we have to do the slope at 2, right? The slope at 2, okay, on either side, the slope is 1, right? Okay, so we're going up 1, right 1, here up 1, right 1. Okay, so the slope is 1, so that'd be 1, okay? So this would be 10 plus 4, or 14, okay? And so that correct answer for 78 would be C. Okay, let's go to 79. So the number of people who have entered a museum on a certain day is modeled by the function f of t, okay, where t is measured in hours since the museum opened that day. The number of people who have left the museum since it opened that day is modeled by g of t. Okay, so we have a function that's adding, right? We're adding people to the museum, and the function that's removing, right? G of t is the people they're leaving, okay? It's the number of people that have removed, okay? So f prime of t is the rate at which people are entering the museum, and g prime of t would be the rate at which they're leaving, right? So using these in combination, you can find the rate of change of the number of people in the museum. So how's the number of the people in the museum changing, right? And so is the number of the, at what time 1 less than or equal to t less than or equal to 11 is the number of people in the museum at a maximum, okay? So to do that, we got to find what the rate of change for the number of people in the museum is, and that would be f prime of t, because that's the rate at which they're entering, minus g prime of t, and we need to solve for where this is 0, okay? Okay, so we're going to look at endpoints, right? We're going to look at the number of people at 1 and the number of people at 11, and then anything that's a relative maximum could be a maximum here, okay? All right, so let's go ahead and put this into our calculator and solve this, okay? So what you want to do is go into y equals and type in the f prime of t function, okay? So that'd be 380, and then parenthesis, and then 1.02. raised to the x, come out of the exponent. Okay, and then we have to minus, and then the g function. So I'm going to use a parenthesis. You could also just, you yourself could have just distributed the negative with the 240 and the minus 240 sign. So that'd be fine. Okay, so parenthesis, and then 240, and then plus, and then 240, sine, and then the fraction bar, and then pi, and then parenthesis, and then x minus 4 instead of t minus 4, all over 12. Okay, we need to close the parenthesis for sine and then close the parenthesis for g of t function. And then I want to come down here to y2 and type in 0. Okay, because I want to know when the difference, right? When this is a new rate, right? So f prime of t is the rate at which people are entering the museum. G prime of t is the rate at which people are leaving the museum. And so this rate that I typed in, this difference f prime of t minus g prime of t, is the rate at which the number of people in the museum is changing. Okay. And so we want to know when this is 0. Okay, so we're gonna go to our window. We only want to look between t is between 1 and 11. So x min, let's put that at 1, and x max, let's put that at 11. Okay, x scale 1's fine. Okay, so we know the sine function goes up to 1 and down to -1, right? So there's a 240 in front of that sine. So it's going to go up 240 and down -240, but there's a 240 that's being added to that, right? So that means that's about 500. So I would say let's go y min at -500. There's no right answer to this, okay? To 500. Okay, it just gives us, analyzing, we can kind of get, close to what we think we might need for the y min and y max. And let's put this at 100. And then let's press graph and take a look and see what happens. Okay, so it's going to happen right here, right? Okay, and you know what? We can zoom in a little bit. So this -500 was too much, really, right? The positive 500, not too bad. Okay, so we're going to go to zoom. I'm going to go to zoom box. I'm just going to get a little bit better of a graph here. I would not do this for the AP exam, okay? Because you're short on time. Okay. Unless you really couldn't just tell if it was just skimming off the top of the x-axis, or really coming below. You might want to do this if you can't see. There's a gap definitely here, right? Okay. So I didn't mark it. Okay, so I want to be a little bit above this maximum on this side. Okay, so I'm going to mark it. That's going to be my top left corner. I'm going to go across, all the way across the screen, and then I'm going to go down and just below my minimum, like right there, okay? And that's going to be my window. And then that just shows a little bit better, okay? So it's definitely happening right here, okay? All right, so I'm going to do second, and I'm going to calculate this intersection, so 5. Okay, so first curve, second curve, and guess, just be close. Okay, so 7.8882, so 7.888, right? Okay, so if you look at this, okay, we have to know when it's going to be a maximum, right? Okay, so from 1 to the 7.888, this is the derivative of the rate this is the rate at which the number of people in the museum is changing. So that means the number of people in the museum from 1 to 7.888, it has to be increasing. So we cannot have a maximum at 1. Can't happen, because this function for the number of people is increasing from 0 to 7.888. I think it's hours. Yeah, hours since it opened. Okay, so the maximum can't happen at 1. It's got to happen here. Okay, and then we start the rate at which people are entering the museum is decreasing right in here, right? Okay, so the number of people in this museum is increasing and then decreasing. This has to be the maximum. Okay, just analyzing it. All right, because we really wouldn't be able to put in the endpoints, because we'd have to have the g function and the actual f function to do that, okay? And we don't have it, okay? We'd have to get the total number of people who have entered minus the number of people who have left, and then we would know how many people are in the museum at those times, and we don't have that information, okay? All right, but just doing the analysis, we can tell it's going to happen right here, okay? So let's go back to our paper, and I know that was a lot of talking and analyzing, but that's the reason why the 7.88 has to be the maximum, has to be. Okay, so we wrote this equation, and we know that this is at t is approximately 7.888 hours, right? And because just before this time, the number of people in the museum was increasing, right? And right after it was decreasing, this has to be the maximum, and it's the absolute one, okay? All right, So that's it. Let's go to number. So number 80, I think, is another excellent question that if I were writing the exam this year, I would be giving you guys something like this, because you can't just Google it and look it up. Okay. All right. So we know that the integral from 0 to 4 f prime of t dt is equal to 8. Okay. So we know that, right? And so we know the integral from 0 to 4 f prime of t dt, and that must equal, since this is a derivative, this has to equal f of 4 minus f of 0. Okay. And then we know this integral, which is equivalent to this, has to equal 8. Okay. So all three of these are equivalent statements. Okay. So that means f of 4 minus f of 0 has to equal 8, obviously. Okay. And f of 0, we can use the table for that, right? F of 0 is 5. Okay. So that means f of 4 minus 5 is equal to 8, which would mean f of 4 is equal to 8 plus 5, which is 13. So the correct answer to 80 is E. Okay. And that would be the work that you would want to show on the exam. Okay. This year. So for 81, the figure above, I think this is another great one that they would ask you on this year's AP exam. Okay. Because it makes you, do you understand what all of this means? Okay. So if g of x is equal to the integral from 1 to x f of t dt, and the shaded region has area of 2, so this has area of 2, what is the value of g of 2? So g of 2, this is what you would need to write up. G of 2 is equal to the integral from 1 to 2 of f of t dt. Okay, so we can use the area for f of t to figure out this integral. Okay, so this integral from 1 to 2, they're telling you that this area has 2. Okay, so this g of 2 would have to equal, okay, now the integral, the area is 2, but this area is below the x-axis, right? So that means the integral would have to be negative 2. So g of 2 is equal to negative 2. Okay, so g of 2 must equal negative 2. And the correct answer, therefore, would be B. Okay, let's go to 82. Okay, so number 82 is a straightforward question. Okay, they're giving you, but there's some work involved in it. Okay, the position of the particles given by this x of t. So that tells you the position on the x-axis for every time value where t is greater than or equal to 0. Okay, and they want to know what is the velocity of the particle at the first instance the particle's at the origin. Okay, so we got to figure out the time that the x position is 0, because that would mean it's at the origin. Okay, so we need to solve x of t is equal to 0. Okay, and that's going to give us some time value, and then we're going to take that time value and put it into the velocity function. Okay, all right, and we're going to let our calculator do all this. Okay, so then we're going to find x prime of that value, whatever that is, okay, which is equivalent to v of that number. I actually should have given more space here. Okay, all right, so we got to figure this number to put here, here, and then we'll get an approximation, okay, for the velocity at that time. Okay, so we got to use a calculator. Let's go to the calc. Okay, so let's go to y equals, and let's clear out the stuff that we have from the previous one. Okay, so x of t is 0.5, and then t to the fourth, so this is x to the fourth, come out of the exponent, and then minus 1.5 x cubed, and then minus 2x squared plus 6t or 6x, and then minus 1. Just double checking, 0.5x to the fourth minus 1.5x cubed minus 2x squared plus 6x minus 1. And we want to leave this as being 0 because we want to know when this is going to be 0, right? Okay, so let's go window. Okay, so let's start x min at 0 because this can happen from 0, and you don't know when this is going to happen, so let's just go 10. And x scale 1, y min, let's go negative 20 to 20. I don't know what the position will be. And let's go by 2s on the y scale. Okay, so it's happening right here, right? Okay, so that's the time where the position is 0. Okay, now there's this origin of this graph, right? But they're talking about the origin of the particle moving on the x-axis, and that wouldn't be when the x coordinate is 0, or when x of t is equal to 0, and that's going to happen at this time, and this time. But they said the first instance it happens, right? So that would be this one right here. So we're going to go. Actually, I'm going to zoom in on this. Okay. Sorry. It bugs me that we don't have, it's too much graph. Okay, so I would go a little bit above this maximum right here. Okay. And press enter and then go across. I know it probably doesn't bug most of you, but it bothers me. There we go. Okay. Sorry. All right. You can laugh at me. All right. Okay. So we want to find this one right here. Okay. So second, calc, 5 for intersect. And let's just get close to that one. And press enter again. And guess we're near it. Okay. So that's it right there. 0.179. Okay. 0.179. Okay, so we want to store this. Okay, so I'm going to go second, quit. Okay, on our home screen, we're going to type x store alpha a. Okay, so we have it stored now, right? Okay, so if we go and we type in alpha window, and we're gonna take the derivative to get the velocity, right? Okay, and it's going to be x of y1, because y1's our position function, and if we take the derivative of position, we're going to get velocity, right? So alpha trace number 1 for y1, and then this is going to happen at x equals a. So alpha a, and that'd be this whole number right here. Okay, so this would be 5.153, right? That'd be the velocity of the particle at time 0.179, okay? All right, so we'll go back, we'll record this, and we'll have it, okay? So this was the time that this happened was 0.179 approximately, right? So this would be 0.179, 0.179, and then this would be 5.153, right? And that's why we're selecting D, okay, for 82. Correct answer for 82 is D. All right, let's go to 83. Okay, so for 83, they're giving you the graph of f prime, and they're asking you which of the following could be the graph of f, okay? So there could be more than one answer, okay? All right, so if you look at this, if this is the graph of f prime, then from roughly 0 to 1, our function would have to be decreasing because the derivative is negative in here, right? So we got to be decreasing, we are. 0 to 1, we're decreasing. 0 to 1, we're decreasing. Okay, so that part's okay. And then because the derivative from 1 to 3 is above the x-axis, right? That would mean the derivative is positive, which would tell you between 1 and 3, the function would have to be increasing. Okay, so from 1 to 3, this function's not increasing, right? All right, so it can't be this one. Okay, and so how about this one from 1 to 3? Yeah, it's increasing, right? Okay, from 1 to 3. Yeah, from here to here, roughly, yeah, it's increasing, right? Okay, and then we have, I should have said this too. Because the derivative is 0 at 1 and at 3, we have horizontal tangents at 1 and at 3, right? And we have a horizontal tangent at 1, we have a horizontal tangent at 3. Okay. We also have a horizontal tangent at 6, right? So 6, yes, that works. 6, yes, we have a horizontal tangent there at 6, okay? Okay, so then from 3 to 4, we're decreasing, right? So 3 to 4, we're decreasing. Okay, that could happen. Okay, and 3 to 4, decreasing. Yeah, that could happen. Okay, 4 to 6, we have to be increasing. 4 to 6, we're increasing. 4 to 6, we're increasing. 6 to 7, the derivative is negative, so that means we from 6 to 7 or 6 to 8. Sorry, 6 to 8, we'd have to be decreasing, and it looks like we are, right? Okay, so now we got to worry about this. Okay, so just to the right of 4, okay, my derivative is negative. Okay, to the right of 4, my derivative would have to be negative. Sorry. I just lied to you. Okay. right here at 4, okay, the right-hand derivative is positive, okay? The right-hand derivative is positive, and it would be here, and it would be here, okay? Right here, the derivative to the left of 4 has to be negative, and it is on both of these, right? Okay, but the derivatives would have to be the same value, because like right here, they're saying the derivative has to be the same. Let me back up. Okay, so the derivatives, I just said that was wrong, okay? The derivatives don't have to be the same, okay? What happens here is the right side derivative is positive because the graph just to the right is above, right? And to the left, it's below. So the slopes to the left of 4 have to be negative and to the right have to be positive. And that happens on both these, right? And there's no derivative at 4 because there's this jump discontinuity on the graph of f prime, right? These are both open dots. So there's no derivative at 4. So why can that happen? That can happen because of a discontinuity, or it could happen because of a corner or a cusp or something like this, okay? All right? So where the left derivative and the right derivative don't match up, right? That can happen, okay? And that's what's happening on both of these. So really, it could be either one of these. We've gone through everything, and really, it's E. So it's either this one or this one because it does all the increasing and decreasing and all of that, okay, correctly, okay? All right, let's go to 84. Okay, so for 84, it says the figure above shows the region A, which is bounded by the x and y axis, the graph of f of x equals sine x over x for x greater than or equals 0, and the vertical line x equals k. If k is increasing at a rate of pi over 4 units per second, how fast is the area of the region A increasing when k is pi over 6? So we want to, this is a related rates problem, okay? We want to find dA dt, okay, when k equals pi over 6. Now we also know that dk over dt, right? K is increasing at a rate, so that's dk over dt. It's increasing at a rate of pi over 4 units per minute. So dk over dt is pi over 4. Okay? All right, so here we go. What is the area of this? So the area would be the integral from 0 to k of f of x, right? And f of x is sine x over x. Okay? And then dx, right? Okay, so when we go to take the derivative of this, okay, we're putting k in here, right? So we're going to have to take the derivative of dk over dt, okay? So when we take the derivative of an integral function, it's just this function, okay? So dA over dt is equal to sine of k. Now that's not x, right? Okay, so sine of k over k, whoops, times dk over dt. Okay, so then we got to find the dA over dt when k is pi over 6 and dk over t is pi over 4, right? So that would dA over dt when, okay, k is equal to pi over 6, okay? So this would equal sine of pi over 6 over pi over 6 times pi over 4. Okay, so I would rewrite this. Okay, dividing by pi over 6 is the same as multiplying by 6 over pi. Sine of pi over 6 times pi over 4. Our pi's are going to cancel, right? And we're going to be left with 6 over 4, which is 3 halves. So 3 halves sine of pi over 6. And sine of pi over 6 is 1/2. So 3 halves times 1/2, which gives you 3/4. So the correct answer to 84 is B, 3/4. Okay? So for question 85, the function f is defined on the open interval 0.5 to 2.4, has derivative f prime given by f prime of x is equal to sine of x squared. Which of the following statements are true? Okay, so we are going to graph f prime of x in our graphing calculator and look and see, okay, f has a relative maximum on the interval 0.4 to 2.4. So we're going to look on this interval to see if this derivative changes from being above the x-axis to below the x-axis, because that would mean f prime is changing from positive to negative at that x value, okay? Just kind of the reverse of this one, the relative minimum, that would be looking on the same interval. We're going to be looking for where the derivative changes from being negative to positive, okay? So from being below the x-axis to above the x-axis, and that would tell us that f would have a relative minimum, okay? And then the graph of G has 2 points of inflection on the interval 0.4 to 2.4. Okay, so now that would be where f prime changes from increasing to decreasing, because if f prime is increasing, that would mean f double prime is positive, okay? And if it's decreasing, that would mean f double prime is negative. So that would mean if it changes from increasing to decreasing, f double prime changed from positive to negative, okay? Or if it changed from decreasing to increasing, that would tell us that we have an inflection point. So there's two ways you can have an inflection point. It could change from increasing to decreasing or decreasing to increasing. And we can look at the graph and determine that, okay? So we're gonna go to the graphing calculator and graph that. So we wanna go to y equals and clear out what we had earlier, okay? And we wanna type in the function sine of x squared. Okay, and then we want to go to our window and we want to change this to 0.4. And then our x max needs to be 2.4. X scale 1's fine. Y min, this is sine, so it's only going to go like between -1 and 1. Okay, so -2, let's just do -2 to 2. And then y scale of 1. And let's go ahead and graph because we're looking between 0.4 and 2.4. Okay, so this is the blue is the graph of f prime, okay? And it changes from positive to negative at this x value, right? Okay, so that means we have a relative maximum at whatever this x value is. Now, it doesn't change from being below to above, right? So the f prime is not changing from negative to positive. So that means there's no relative minimum, okay? Let's take a look at the inflection points, okay? Is there any? Okay, so the function, okay, so the f prime is increasing here. F prime is increasing to right about here, okay? That would mean, okay, that f double prime is positive. After that, f double prime is negative. So f double prime changed from positive to negative, and we can tell because f prime changed from increasing to decreasing at this x value right here, whatever this x value right here is, right about there, okay? And then, okay, if you look, okay, it's decreasing, f prime is decreasing, and then it changes, and then it's increasing, okay? So that would mean f double prime changed from being negative to being positive, okay? So we have another inflection point right here. So we have 2 points of inflection from 0.4 to 2.4, okay? All right, so let's go back and we'll answer this. Okay, so once again, we knew there's a relative maximum because f prime changed from positive to negative. It never changed from negative to positive, so this one's not true, okay? And then it did change from increasing to f prime changed from increasing to decreasing. So we had, and then it also changed from decreasing to increasing. So we had 2 points of inflection, okay? So the correct answer is 1 and 3 only, which would be D on this, okay? All right, let's go to 86. So they're talking in number 86, the position of a particle moving the x-axis is given by the twice differentiable function x of t. So x of 2 is less than 0. Okay, so that means the position is negative. And so if it's negative, we're on the left side, okay? And then x prime of 2 is less than 0. That would mean the velocity is negative, right? So we're on the left side and moving left, okay, which tells me we're moving away from the origin, okay? So we're moving away from the origin, and we also know that the velocity is negative, and also the acceleration is negative, okay? So if velocity and acceleration are negative, then the particle's speed would have to be increasing or speeding up, okay? So the particle is moving towards the origin. Okay, it's moving towards the origin if position and velocity are opposite signs, okay? And they're not, they're both negative, right? So we're moving away from the origin. So we can actually even ignore B, right? The particle's moving towards the origin. It can't be, okay? The particle's moving away from the origin, yes, okay? So for these, the particle's moving away from the origin, and because this is velocity and it's negative, and this one's acceleration and it's negative, you've got to be speeding up, or the speed has to be increasing, okay? And so the correct answer is for 86 is D, okay? All right, so particle, let me write this so just to make sure you understand, okay? The particle is moving away from the origin, okay? And it's because x of 2 is less than 0, and x prime of 2, which is, sorry, I put x squared. X prime of 2, which is equivalent to v of 2, is also less than 0, okay? So it's on the left side of the origin, and it's moving left, so it has to be moving away, okay? And they're talking about decreasing speed, increasing speed, okay? Speeding up, well, the particle's speed is increasing. Increasing speed is increasing, same thing. Okay, and the speed is increasing because x prime of 2, which is equal to v of 2, and that's less than 0. And we also know that x double prime of 2, which is equal to a of 2, is also less than 0. So we're moving left at d at, and that, don't ignore that, okay? It's the acceleration and velocity both have the same sign that causes let me explain it this way. So we have a negative velocity, right? Because it's less than 0, okay? And we're adding negative velocity each second to that. So that's why it's speeding up, okay? Because we know the acceleration is adding more negative velocity each second to that velocity, okay? All right? Okay, so the correct answer is D, okay? Okay, the formal write-up on this is I want to do this. Okay, so I'm going to let g of x be this function, this integral function from 0 to x cosine of e to the x dx. So it's an integral function, right? Because, and then we're going to find this b that causes this function to be a minimum, okay? All right, because g of b would be where the minimum happens, and it's between 0 and 2, okay? Okay, so what we want to do is we want to find g prime of x. Now, g prime of x would simply be cosine of e to the x, okay? And what we want to do is we want to solve for where that is equal to 0, because that's going to give us the critical values, right? So we're going to use a closed interval test, okay? Or it's called the candidates test too. So this is equal to 0, okay? And we really only need to focus in on these that are going to be relative minimums, okay? So we only need to focus in on where this is going to change from being negative to positive, okay? So we're going to go to our calculator and solve this, okay? If it changes from positive to negative and there's a 0 there, right? Okay, then that would mean it's a relative maximum. So it can't be a minimum if it's already a relative maximum, okay? So we're gonna rule out the ones that go from positive to negative because of that. Okay, so we're going to go to our graphing calculator and graph this. Equals, okay, we're going to clear out what we have, and then we're going to put in g prime of x, right, which is cosine of e to the x. Okay, and our window, we're looking for this x value where this happens, which we happen to be calling b, and we're only looking from 0 to 2, so that's all we have to focus in on. So x min is 0, x max is 2, x scale of 1. Because it's cosine, I would go like -2 to 2 again, okay? So let's go ahead and graph this and see what happens. Okay, so this one is a relative maximum right here. So we don't even need to worry about this one because it's changing from positive to negative. And that means it's a relative maximum. Well, if it's a relative maximum, it ain't going to be a minimum, right? Okay. So let's find this one because that's a relative minimum. Okay. So second, calc, and then we want to find the intersection. So 5. So first curve is the derivative curve, and then let's just move over close to that where we want to find it, right there. And then guess, just go ahead and press enter. And 1.550. Okay, so I want to store that, and I'm going to do the integration. I'm going to find g of 0, g of 2, and then g of this 1.55. But I need to store this, right? Okay, so second, quit. Okay, and then I'm going to go and I'm going to press X and then store. Sorry, I had to think for a minute. So alpha A. Okay, so that's my A, right? Okay, so I'm gonna now. Okay, so I solved this. I'm gonna go back and write all this up formally. Okay, but okay, we solved this, and that's the x value. Okay, and then we need to do the integral g of 0, right? And g of 0, if we look at it, that would just be the integral from 0 to 0, right? So that would just be 0. Okay, and then we need to do this one, which is the integral. Whoops, I pressed the wrong one. Alpha window number 4. Okay, and we're going to go from 0 to what we just stored as A. And we're integrating y1, right? The derivative cosine of e to the x. So we could just type in y1. Okay, and then at x. And it gives us this value, right? And then we also need to do it at 2 because those are the endpoints, right? Remember, it's a closed interval, so we need to check the endpoints. So alpha, window, and then number 4, function integrate. So 0 to 2 of alpha trace number 1, and then dx, right? Okay, press enter. Okay, so this one's smaller, right? So this is where it's going to happen. This is where it's going to happen for a minimum. The minimum is negative 0.536, and it's going to happen at this a value. Okay, so let me go back and we'll formally write this up. Okay. Okay, so this happened at x is about 1.550, right? And we stored that as alpha A in our calculator, okay? And then we found g of 0, okay? And g of 0 is the integral from 0 to 0 of cosine of e to the x dx. And because we're integrating from 0 to 0, we know that's 0, right? And then we need to do g of 1.550, and that'd be the integral from 0 to 1.550. And we're using more than that, right? Of cosine of e to the x dx. Okay, and that turned out to be negative 0.536. Okay, and then we also need to do g of 2. Now there was another one where this happened, right? But we're ignoring it because we're asking for the minimum, and that other one would have to be the maximum, right? Okay, so g of 2 would be the integral from 0 to 2 of cosine of e to the x dx, and then that gave us a value of negative 0.228 rounding. Okay, so this one's the smallest, right? So it's going to happen at this x value of 1.550, and that's what we're calling this b, okay? So b has to be 1.550, and so the correct answer is D. Now this is all using calculus, okay? Whoops, I didn't realize you guys couldn't see it. I'm sorry. I really get mad at myself when I do that. Okay, so this is what we got, right? So this is what's important is we're looking for a minimum. This is what we're trying to find the minimum of. So we had to take the derivative of it, right? Okay, and I just called it a new function, g of x, right? And I can do that. And this is happening at this b value, okay? All right, and it's right here at 1.550. Okay, let's go to 88. Okay, so I want to really point this out. There's a common mistake on this one. okay, and you're trying to put in 0 into x here, and you're trying to do a direct substitution, and I'm going to tell you that doesn't work in this problem, okay? All right, so what happens is this, okay, we got to look at the graph of 1 minus x squared, okay? So to do this limit, okay, we have to find the limit as x approaches 0 from the left of f of 1 minus x squared, okay? And to do that, we have to do the f of the limit as x approaches 0 from the left of 1 minus x squared, okay? And this is going to become another limit, okay? Now, 1 minus x squared, okay, so 1 minus x squared, okay, negative x squared is an upside down parabola, and it's been shifted up, right? So it looks like this, okay? Right here is 1. Okay, so this is the graph of y equals 1 minus x squared. And this point right here is the point 0, 1. Okay, so as you do this, as the limit as x approaches 0 from the left of 1 minus x squared, we're getting closer and closer to 1, but from underneath 1, from less than 1, right? From less than a y value of 1, because we're below the 1, okay? So this becomes the limit as x approaches 1 from less than 1, right? From under 1, that's what the negative means, okay? From smaller values of 1 of f of x, okay? And if we look at this, that'd be now we can use this graph of f to do this, okay? As we approach 1 from the left, we're going to get 3. This is equal to 3. Okay, what if we do, and so we have to do the one-sided limits, and if they agree, then that's going to be our limit, okay? So then the limit as x approaches 0 from the right of f of 1 minus x squared is equal to f of the limit as x approaches 0 from the right of 1 minus x squared. But if we approach 1 from the right, we're getting closer and closer to 1, but from values underneath 1. So this becomes another limit. This becomes the limit as x approaches 1 from underneath, right? From below 1, okay, of f of x. And that's also equal to 3. So the answer to this is 3. Now, most of you would probably go to the non-existent, right? Because there's this jump discontinuity, okay? But that's not true, okay? It's actually 3, because as we put 0 into this, we are approaching 1 from the same direction. We're not approaching 1 from different directions, okay? We're because of the way this function behaves, 1 minus x squared behaves, we're actually approaching 1 the same way, which is going to give you the same value of 3, okay? So for 88, the correct answer is C, okay? All right. So when they ask you limits and they give you graphs and stuff like this, I would really, really encourage you to do the one-sided limits to see if it works out. Okay. So yeah, the correct answer to number 88 is C. All right. So let's go to 89. So for 89, the velocity of the particle on the x-axis, they're giving you that, okay? And for 0 less than or equal to t, less than or equal to 2, what is the total distance traveled by the particle between 0 and 2? Okay, so that's what we have to do is integrate not the velocity function, because that would be the change in position, okay? That'd be the displacement. What we have to do is we have to integrate the speed function, which is the absolute value of v of t, okay? So what we need to integrate is 0 to 2 of the absolute value of v of t dt. And whatever we get, and we're going to do this in the calculator, okay, that's going to give us the total distance traveled, okay? All right, so we'll put it in the approximation, and we're going to go to our calculator and do that. So we want to go to integrate, right? So alpha, window, and then number 4. And then we're going to integrate 0 to 2. And then absolute value, so alpha, window, and then number 1 will give us the absolute value. And you could put we're only going to use this one, so you could put the function in for y1 and then just use the y1, or I'm just going to type in 2 and then minus t squared, so minus x squared, and then sine of x. Okay, and then get out of the absolute value part and go to x. And we get 2.539. Okay, so 2.539. Okay, so let's go to our back to our paper. So for this integral, we got 2.539, and so the correct answer is D. Okay, let's go to 90. Okay, so this is number 90 is a related rates problem. A cup has the shape of a right circular cone. Height is 12. Radius of the opening is 3. Now this is the cup, not the water level, right? So we have this cup. It's a right circular cone, right? This would be our radius of the cone. And then coming down, this would be our H. Okay, we know volume, okay? And we also know that, so we know V is equal to 1/3 pi r squared H. We also know that dV dt, the volume is changing at a rate of, and it's increasing, 2 cubic centimeters per second, okay? So 2 centimeters cubed per second, okay? And we know, you know what, I shouldn't have written R and H here. Let me fix that, because that's fixed, right? That's not changing, okay? The water level is gonna be changing, but this is gonna be 12, and the radius of the cup is 3. So I should have put those numbers in, okay? Now we have a water level, right? Okay, that water level has a height of H and a radius of, that top part of the water has a radius of R, okay? So what is the rate at which the water level is rising? So we wanna find dH over dt, okay, when the depth of the water in the cup is 5 centimeters. Okay, so find dH dt when H is equal to 5 centimeters. Okay, so we need to convert this so it just has V and H. Okay, and the way we can do that is we can do similar triangles. So 3 is to R as 12 is to H. Okay, so that would mean 3H is equal to 12R. Now, I want H, right? I want H in my formula here. I don't want R, okay? So I want to solve this for R. So that'd be 3H over 12 is equal to R, or H over 4 is equal to R, okay? So that's always true. The radius is always going to be a fourth of whatever the height is, okay? So back over here, in the volume formula, right, we have volume is equal to 1/3 pi r squared H. I want to rewrite this so it's just V's and H's and then take the derivative, okay? So this R right here is going to be replaced with H over 4 because those are equivalent. That's what this says. It's always equivalent, okay? So V is equal to 1/3 pi times H over 4 squared times H. Okay, so this would be V is equal to, I'm going to write pi over 3 times H squared over 16 times H, okay? And then 3 times 16 is 48. So this is volume is equal to pi over 48 H cubed, okay? I can take the derivative with respect to time now of both sides. Okay, so this left side becomes dV dt is equal to, and this is a constant times h cubed, so this would just be pi over 48 times 3h squared. Now, if we'd be done if we were taking the derivative with respect to h, but we're not. We're taking the derivative with respect to time. So we have to multiply by the chain rule. The derivative of h with respect to time would be dh over dt. Okay, so I know this dv over dt is 2 is equal to pi over, okay, this 48 is 3 times 16, so this becomes pi over 16 times h squared, and at this moment in time, h is 5, right, that we're trying to find. So 5 squared times dh over dt, okay? So that makes 2 is equal to 25 pi over 16 times dh over dt, okay? Multiplying both sides by 16, I would get 30. I just realized you can't see it. Dang it again. Okay, so this, multiplying both sides by 16, I get 32 is equal to 25 pi times dh over dt. Dividing both sides by 25 pi, I get 32 over 25 pi is equal to dh over dt. Now my height, so let me write this, dh over dt is equal to 32 over 25 pi. My h units are in centimeters and my time unit is in seconds. So this is 32 over 25 pi centimeters per second, okay? So the correct answer for number 90 is A, okay? So going back up, looking at this, okay? The correct answer for number 90 is this A right here, okay? That's it for number 90. So really on question 91, they're telling you that the number of students in a school who have heard a rumor at time t hours is modeled by the function p, okay? And the solution, and that's the solution to a logistic differential equation. So at noon, 50 of the school's 500 students have heard the rumor. Also at noon, p is increasing at a rate of 20 students per hour. Okay, so they're telling you right here in this part, dp dt is 20 at this time, okay? So dp/dt, if you look at these rates, these are all dp/dt's, okay? So that's the rate at which the number of students who have heard the rumor is increasing or changing, okay? And they're telling you it's 20. Now, it's dependent upon the population, and what I mean by population, it's the number of students who have heard the rumor. So at noon, the rate at which it's changing is 20, but also at noon, the population that's heard the rumor is 50. So what we have to do is put 50 in here and see which one of those gives you the rate of 20 students per hour, okay? So if you try this first one, dp dt at p is equal to 50, that'd be 1 over 1125 times 50 times 500 minus 50, okay? And if you put that into your calculator, okay, what you would get out is 20, okay? So that's it right there. And there's no way that you're going to get 20 because all of these other numbers, you're still, all of these are p times 500 minus p, right? And the only difference is these fractions you're multiplying by, and this is the one that gives you 20. And if you try them and all the rest, it won't give you 20, okay? So the correct answer is A for 91. Okay, so that's it. So for 92, they're saying let f be a positive continuous decreasing function, which is all the conditions that need to be met in order to use the integral test. And this is a problem where you have to know the integral test, okay? So this integral from 1 to infinity of f of x dx is equal to 5, okay? And, okay, which of the following statements about the series must be true? Okay, so I'm gonna go over something that I didn't cover in class because it's rarely used, but we need it for this one problem, okay? And it's this, okay, for n equals 1, this integral is always going to be less than or equal to this sum, okay? So we have the integral from 1 to infinity of f of x dx is always going to be less than or equal to sigma, the series, n equals 1 to infinity of f of n, okay? And this series is less than or equal to f of 1 plus sigma n equals 1 to infinity f of n, okay? Now, what this means is that the series, okay, has to be greater than 5 because this is the integral is 5, right? So since this is this is telling you that this integral converges, and because f is positive, continuous, and decreasing, and the integral converges to 5, okay, then we know that this series also must converge. So that's only, we know it's either B or D. It doesn't say what it converges to, okay, but we know it converges, but it's always going to be larger than the integral or equal to it, okay? So that means the only correct answer for 92 is D, okay? I didn't go into this error bound when I did the integral test because we were more worried about, okay, does it converge or not converge, okay? All right, and this is the first time I've ever seen it where you have to know this statement right here, okay? All right, I wouldn't worry too much about this, okay? If I was taking this test, I would just go, okay, you know it's one of these two and just make a guess, I would say, okay? Because really this is not used very often. Okay, guys, so that's it for today. That's it for the 2016 exam. I'll be seeing you tomorrow. All right, take care. Bye.